Hello, everyone. Welcome to the Fluent Bit Office Hours number 81. And today's session, we are going to walk through the source code of Fluent Bit, how the project is structured from a folder perspective, how the plugins are placed in a very general high-level architecture, so you can understand as well how to build this from scratch in case you want to play with it or you want to do your own customization on top of Fluent Bit. So we're going to just jump into the quick intro that we have. And thanks our sponsors, Chronosphere, for hosting this office hour. And as mentioned before, who's speaking, I'm one of the maintenance creators of this project. I have been around from the CNCF and Linux Foundation for a lot of years, so I'm very familiar with the cloud native ecosystem. And the goal of these office hours is to have a bi-weekly space where you just can jump in, talk to the maintainers, or just send us your question, offline, and we can address them then when we go live. Here's in the bi-weekly Fridays. And what you can expect, short walkthroughs about different topics. This is not a complete course, but we try to have a very laser focus on certain topics of the project. Share tips and tricks, and as well invite you to participate as I'm doing it right now. So we're going to have more speakers, over the coming Friday sessions. Okay, as you know, Fluent Bit is a telemetry agent that in order to work, it connects data from multiple sources and send the data to multiple destinations. Now, how this works behind the scenes, it's where we're going to dig right now. As you can see, for example, when an agent like this has like a pluggable architecture, pluggable means like we can plug to any type of service. From a code perspective, that means that, hey, we support plugins, right? So we have kind of very specific interfaces that says, hey, if you want to ingest data into Fluent Bit, this is a way to do it. And we express that through plugins that just care about to receive or collect information and transform that information to the format that Fluent Bit speaks internally, which is a message pack. Okay, so let's dive into the source code of Fluent Bit. And we're going to do it from scratch, doing a fresh clone from GitHub. So I'm going to jump into my terminal here. And I'm going to do a fresh clone. Oh, thank you. The autocomplete is really good. I'm going to do a dep 1 on this clone, so we don't get the whole history from 10 years from the project. So I get faster. I'm going to do this Fluent Bit 81, which is the office hour number. So the whole content will be in this directory. And that was a really fast clone. So when we get into Fluent Bit 81, you will see that a couple of files and a couple of directories here. Now I'm going to import this project inside my editor, which is a Visual Code. I have other projects here, but I'm going to add a new folder, add folder to project. And this will be Fluent Bit 81, that is here. Add. So we're going to play with this repository. So I wanted to use this because I wanted to show you how it is structured. Okay, so in Fluent Bit, there are two main directories that you will care about. We call them what is the core of Fluent Bit, all the functionalities, interfaces to deal with data encoding, scheduling, retries, buffering. And we have others to host all the plugins. So for example, if we get into the SRC directory, we have our directory for AWS authentications, a configuration format, so how we manage the configuration files, which support the classic configuration mode of Fluent Bit, and this is how we do it in YAML. And so we have also as well a little abstraction that when we load the abstraction, it detects if a file is a classic mode, which is called Fluent Bit, or the YAML version. We have as well our built-in HTTP server interface, where we just registered all the API's endpoint that we have in Fluent, mostly for metrics and to check the health of the project. So this is the health endpoint, the metric endpoint. This is for V1. It's kind of the old version where you get mostly JSON version of this data. And besides the HTTP server, for example, we have other interface that is called multiline. As you know, Fluent Bit comes with a strong background on processing logs. And one of the biggest challenges that we got in the past was like when you're running an application that sends their login messages in multiple lines, in most of the log agents that exist in the market, every single line will be represented as an individual independent log message, right? But in reality, you have to put all of them together as a single message so you can get the notion of what it means. A common use case for these are kind of imagine stack traces. If you're running a Java stack trace application, a Java application, this crashes, you're going to get a stack trace, and that stack trace might have maybe 100 lines, and I'm sure you would like to have that in order. So multi-line, what it does is an isolated component that create rules and knows how to assemble individual log messages in the right order by following certain patterns. We're not going to get deep in how this is built internally. However, multiline is consumed by the tail plugin, is consumed by the filter multiline plugin that we're going to see later. But let's take a look, for example, multiline is here. Let me close this pane here. This is kind of how it works internally. But let's see how we ship built-in parsers ready for specific use cases. For example, if you use Golang, we don't let the user to configure the Golang multi-line parser. We just ship one which is built in. And basically, the way that it works, and you will see it if you have configured multi-line messages before, this might be familiar for you. We just create rules that sets what is the start state, what is the regex pattern that I'm to match that start state, and what is expectation from the following line. And you can have multiple rules that change together. And this is just here. So at some point, if there's a new stack trace around, you might find there is no Rust here. So if you want to contribute a parser for Rust and ship it built in here, hey, this is a good way to do it. Okay, a multiline, as I said, yeah, this is a straight isolated interface that is consumed by multiple components. Proxy. While everybody understands proxy like, hey, I'm going to proxy this data from this endpoint to the other, in our case, it's different. Proxy is an interface that we have in order to invoke Golang plugins. As you know, there's a CGO interface. So in this directory, you have the interface to register the Golang plugins, where if you build a Golang plugin for Fluent Bit, which will be a shared object, at some point you have to expose certain functions in your Golang code. And these functions become symbols in the binary. And when we load the plugin, we look for those symbols because those symbols represent a memory address, right? Which represent a function that you want to invoke. In our case, we define that we have FLB plugin init, the flush callback, the flush with context, the exit, and so on. So we create, for example, a structure that defines this is a plugin and these are the functions. So when Fluent Bit starts, it's going to start calling certain functions. And it's called a proxy because it's aimed to be like a small, thin intermediate layer to code this code. Okay, record accessor. Record accessor is a way that we have to specify or access certain keys or subkeys from a log record. So it's a way that we have patterns. For example, you can say $, the name of the key, and you can specify the subkeys. Maybe in order to show you this in a better way, what is it? Let me close here. We can go to Fluent Bit documentation. I think we have record accessor. We have a section for record accessor where we specify, for example, we have this structure. This is how you can access certain values of certain keys or subkeys that exist. Yeah, and certain components, and not all the plugins, but some of them support record accessor patterns like grep. So for example, you want to match all the records which the labels, colors, matches something that is blue. And they say here you have an example. Now, how this works internally, record accessor, let me close this. Record accessor is one primary file that has the kind of the definition of where the parser exists. And for everything that is from a parser perspective, because we are parsing patterns inside from a configuration file, what we do is like we define, we use flex and bison. So lex and bison or yak, right? Which is a very old way to specify grammars. This is very, very old ways to parse, certain text. So we use these utilities. Here we have, or as you know, I don't have colors. I have not touched this file in years, and this is how the patterns works, the definitions. Okay, so record accessor allow us to access certain. You get a message internal in Fluent Bit, and you want to access certain key or subkey. You use this interface for that. SIMD-UTF is a new interface that was recently added. Just is to play with UTF by using a SIMD external library that is called SIMD-UTF. So this is kind of, I think that's the only C++ code that we have, since SIMD-UTF is written in C++, which is an external dependency. And this is how we connect to it. Not big deal, not something that you would like to touch right now. Then we have the stream processor. A stream processor is an interface that we have in Fluent Bit that runs after the filters. As you know, we have input processors, we have filters, and then we have the stream processor that what it does, by using a SQL instruction, you can tell it to retrieve certain records that comes from a specific input and aggregate them or route them with a different tag over the pipeline. And this is how it's implemented. This is how we add the SQL function. So if you want to do something with it, here's how to do it. And we have a subdirectory called parser where, similar to record accessor, we define, how to trap certain functions. For example, it's an average function, a sum, a count. Here we have the grammar. For example, if you want to create a stream, this is how we define this in the parser. So when you compile Fluent Bit, that's why it requires to have Bison and Flex in your environment, because it's going to take these source code files and translate them in C interfaces that then we consume to do all this stuff. The next one is TLS. So a recap, we are looking at the core functionality of Fluent Bit internal interfaces right now. TLS. In the past, when Fluent Bit started, we didn't have networking support. It was not needed. Then we added that. And then TLS as secure channels came in. And at some point, we started by supporting the library called Embed TLS, which is from ARM. And we found that, we didn't found, so community found that Embed TLS, while gets the jobs done and the API was kind of simpler to use, it didn't have the optimizations that OpenSSL had. And the thing is like, hey, when it's about doing TLS handshakes, and if you're sending so much data, doing encryption, performance matters, right? And at some point, we worked with the community, and we had Embed TLS at one point. Then we extended to OpenSSL, but hey, nobody was using Embed TLS, right? When they were using Fluent Bit. So and since every Linux box around or Windows Server has OpenSSL or any variant available, yes, we just went to the default with this. So FLB TLS provides kind of high-level interface to access a specific SSL functionality. For example, check the host names, read from a channel, from a socket, right? And internally, what it does is to call the API callback, that these API callbacks, for example, are defined in the backend that TLS provides. So as you can see, this is an OpenSSL backend that we have. That is, this of course is exposed by the TLS wrapper. And here we have all the functionality. So when you get a SSL error, this is not working, or the connection has been closed, or the certificate is not valid, it's coming from here. Okay, so these are kind of files that we don't want to touch that much unless we find an error, but I'm just telling you this as a reference. WASM, as you know, we support a WASM in Fluent Bit. WASM is a way to use different languages to translate to a specific bytecode that is called WASM that you can run in Fluent Bit. So we have a specific interfaces, like you can write plugins in Go by using the Go-like interface that we have, or you can write it in Go by using the WASM interface. Okay. Okay. So these are the main directories of the source code, the core. This is Fluent Bit core. And then we have all the other C files that implement and provide different interface, for example, for base64 encoding, for example, chunk trace, for wrappers for compression. Config map is a way that we support the config map in the plugins. Which one is interesting? Downstream is an interesting interface. For example, any plugin that provides a TCP server or an HTTP server use the downstream interface to set it up, the socket, provide the SSL communication, and all the low-level things that we don't want to re-implement on every single plugin. Then the first one, well, this is one of the first files that we got in Fluent Bit, is the engine. The engine is pretty much the event loop. When Fluent Bit start, maybe let's jump into that. So like a quick walkthrough. Where is the Fluent Bit? Okay, the main file is fluentbit.c. This is kind of what we call the binary, right? And this is with the one that has the main entry point, the main function. And when Fluent Bit starts, these are the options that you commonly see in the documentation. Those are here. You can extend them if you want. And when it parts all the configuration, start adding the stuff, at some point, just get into a main event loop. Oh, it's growing a lot. Here. This is where Fluent Bit start after all the configuration have been set it up. And when we start, I'm just not going to walk through every single step, but I'm going to tell you that the main thing is the engine. Oh, wait, it was close. It was here. Okay. The engine, when we have event for, wait. Okay, this is the main event loop. Here's where we have a while one. Of course, this loop might break if you exit Fluent Bit. So event wait is like it starts waiting for all the events to happen in Fluent Bit. Events means if a plugin was started and that plugin wanted to have a timer that is triggered every 2 seconds, that will be seen here. And when that timer is triggered, this will invoke the plugin that was asked to be invoked when this event happened. And then we have as well the concept of the schedule, reschedules, how we process the tasks. So every time that Fluent Bit collects some data from an input plugin, that information is going to be passed to the engine through the channels, right? So we have a ring buffer for that. It's going through the channels, and then the engine will say, hey, we have a new buffer. I'm going to take this, put it in the queue, and when it's time to flash, means time to send the data out, it creates what it calls a task. And a task says, hey, this is the data, and this is where it needs to be routed. And if you are interested in learn more about a task, it should be here, FLB task. This is how tasks are handled. Okay, so this is Fluent Bit core. Okay, I think that's a very quick overview. And we have the socket management here. As you know, some plugins as well needs and want to have states. Like for example, the tail plugin or in input Kubernetes events, we want to have a state to say, hey, this is the data that have been consumed from this endpoint, or this is my checkpoint. If I'm restarted, or I'm going to resume from that specific checkpoint. And for that, we have a wrapper for SQLite. We support SQLite in Fluent Bit. So every plugin can say, I want to have this database file, and we have an abstraction that simplifies the creation, the options of, the path description of all of that. And then UTF staff, utils workers to spawn threads, and compression. This is a wrapper for compression, and so on. Okay, this is the core. Now, I'm going to step for a second, and now we're going to jump into compile Fluent Bit. Okay, I don't know if you remember, we were in this repository that we built, and this is the same thing that we were looking at, right? We were inspecting the source code on SRC, and now we're going to, in order to compile it, we're going to get into the build directory. Why we want to get into the build directory? Because when you start compiling the project, there's a lot of configuration steps, a lot of files are created, and you don't want to have all those files here. You want to have in a different folder that if you want to delete the folder, it's pretty safe to do it. So we always use the build. So build is an empty folder that we ship. You can use whatever you want. And the way to get started is to run CMake. So CMake is that we use in this project in order to configure, build, and provide certain options. I'm going to provide the options since I'm always kind of developing. I'm going to enable all the tests, all the stuff. I'm going to turn off 6 support, I think because I didn't have the compiler or something like that. But I'm going to run CMake. So what CMake is checking, do I have the right compiler? Do I have these options? Does the system understand the system call is available, not available? Because based on that, when Fluent Bit is going to compile, it will use those definitions to say, oh, this functionality is available. And one example is, imagine that you're running on Linux, and Linux we ship, for example, CPU metrics, right? But maybe those CPU metrics are not available if Fluent Bit is built on Windows. So we have some conditions for that. Okay, so now Fluent Bit has been configured. And if we inspect the content of the build directory, now you will see we have a lot of things here. Okay, anytime you can delete this and it should be fine, but you have to run CMake again. Now, the next command is to just build Fluent Bit, right? Make, and of course, you always like to use -J to use more cores and not just one. I always use 16, 32, it doesn't matter. And let's spend the time to see how long it takes to build from scratch on this specific machine. So this is a small Linux server that I have at home. And it's a Minis forum. So yeah, this is a machine where this is being compiled. Yes, okay, here's the processor. It's kind of decent, so it takes like a minute to build from scratch. But of course, when you are developing or testing out in Fluent Bit, in my personal workflow, I'm not compiling from scratch, because usually the next time that you build make, it will try to see which objects has changed of the code that you modified. And yeah, it will be faster. Yeah, we can do an example right now. Yeah, let's customize Fluent Bit, do some dummy stuff so you can take a look at it. Okay, so right now it's just compile the course, compiling the plugins, external libraries, and not libraries, but other libraries that it creates for its own purposes, because it's also testing the unit test system, which is we are going to walk through right now. Okay, so it took 1 minute and 4 seconds. I hope that we can get a faster machine maybe. Then during the next year that gets this in 30 seconds. Okay. So now if you inspect the content of the bin directory here, you will see that it creates a bunch of files, okay? Some of them are what we use for development. Some of them are just unit tests that you use locally. The principal one, of course, is the Fluent Bit binary. That it should be bin Fluent Bit, that is here. When you run Fluent Bit from the command line, this is it. This is get started. But as well, for example, we have other files that here that has a prefix. It's kind of flb-it, which means internal test, right? And this we're going to get into testing. And then we have others that are called RT, which means runtime test. And what is the difference? If you build an interface in Fluent Bit, for example, imagine that we create a multi-line component. You would like to add some unit tests for that to make sure that when you are running that interface under success and failure scenarios, there's no memory leaks, there's no corruptions, and so on. So you try to add do a lot of things in the unit test. And yeah, let's run one unit test. Let's, what is the multi-line? Yes, here. Should be FLB, IT, multi-line. And that internal test has as well a couple of other internal tests, the unit tests that exist inside this file. Now, let's inspect the source code of this file so you can understand how it's structured. Okay, inside Fluent Bit directory, if you go to test, you will see two primary, well, the principal ones that are internal and runtime. So you go to internal, and here are every single unit test file. Now, what is the difference? If the file is called, for example, multiline.c and it's an internal test, the binary will be prefixed with flb-it-multiline. Here you go. And the multiline file, every unit test is kind of the same. Go scroll down, and you will see this structure where you define what are the name of a unit test and what is the function inside the same file that is associated to that. So as you can see, we have the same one here. And the good thing is, like, if you just run it without any argument, it's going to run every single unit test and said, hey, everything has passed, there's no problem. And if you want to be safe that there's no memory leaks, one thing that is running, not crashing, but the other is like, hey, do you have leaks or something? You run it with background equal full, and we should not have any leak. And we don't have any leak because it says in use at exit 0 bytes. And this is how the development happens. Yeah. You write the interface, you try to run some unit tests, try to do unit test that works, expect it to fail, and then run it with background before sending the PR. So I think that is a good practice. Okay, so this was run in general for all unit tests, but at some point you would like to run not all of them, just a few of them. I just run with the -L so I can see which unit tests I have. I imagine that, okay, I want to just run parsed Java. I just append the name of the unit test, and that's it. It's going to run the single unit test. And why is this? Because there are unit tests that are very, very long, and they start the runtime, and I don't know, they're like 100 unit tests for a simple plugin, and that might take a few minutes. However, there's a work that is one of the contributors in my field is working on, which is trying to parallelize this internal segment. So I think that CI will get faster, but of course, we always recommend to do this locally. Okay, this is how this works, internal test. Now, we have, for example, since I just mentioned long unit tests, let's take a look at the runtime test. And there's one for the Stackdriver plugin, which is from Google. If I do -L, you will see all the tests that they have. Look at this, beautiful. And beautiful because, hey, this is well tested on all single scenarios. But if you start to running, yeah, it might take some time. So it will start Fluent Bit right from scratch, one test after each other. Now, having tests in C language are not ideal. I personally think it's not ideal because it does not encourage you to write tests. However, we're looking for ways now how we can abstract that and have this test, the definition of a test in JSON or in YAML. So everybody can just create it and put the stuff that they need easily. Okay, so this is Stackdriver runtime test running. The other ones that has a lot of things is a Kubernetes filter, -L. So I think it has, oh, this is close to Stackdriver, right? So it just checks how it mimics that it's connecting to a server, that it got certain data, and it validates the options that were enabled for that filter, if the annotation exists with an invalid text, with different parsers, what happens in multiple containers with different streams, std out, std and so on. And when you run this, and all the scenarios, of course, you want to run it with Valgrind and the development. Of course, when a PR is submitted to GitHub, you will see that some actions are running. And maybe let me show you that. Okay, so for example, go to Fluent Bit repository and we go to pull request. You will see that sometimes unit test fails in the environment because the environment said, hey, I want to stop this, and you had to rerun it. But however, let's try, okay, so there's a PR here that was created by Hiroshi that tried to isolate on email headers for building the process. And okay, he's showing what he changed, the why, and so on. Pat approved this from another perspective. I don't know if you are not maintaining, you can see this, but if you open up this, you will see all the tests that were run. So the unit tests that we have defined inside the source code, when you submit a pull request to GitHub, right? What will happen is those tests will run on different. So your branch will be built for Windows, for Mac, for Linux, and will be compiled under GCC, Zlang, and Zlang compiler, and with different compiling options. And it's a huge matrix of builds, right? It's like 87. And you will see that we turn coverage on, jmalloc off, jmalloc on. We use GCC. In other ones, we don't use Valgrind in the CI, but we use the memory sanitizers. So every time all things are tested. So for example, this test, we just implemented the SIMD stuff, and we want to make sure that all unit tests works JSON encoding with SIMD off or SIMD on. So this is a way to reduce, the chances to mess it up with the project. But it's good. So this is a really good example. Not going to merge this because we want to review it. Maybe we can do a review session in another office hour. But I wanted to connect you how we have the source code, the interfaces, how we create internal unit tests, runtime tests, and how this connects with GitHub CI and why those are really important. Okay, so let's back to Fluent Bit. Okay, we were talking about tests. Okay, when you run Fluent Bit, you have the -h. Maybe you have never used Fluent Bit from the command line because you're shipping from a container with a config file, and that's fine. But if you run -h, you will see all the options that you have available. And there we have the plugins, right? The inputs, the processors, the filters, and the outputs. And you can run Fluent Bit from the command line like this. Fluent Bit -e, which means the input. I'm going to say, hey, use the random input plugin, and the output send what the data has been collected to the standard output. And every second, you're going to get a random value on the screen. Right? And sometimes when we're developing, we do this, right? Or you're just going to enable your own plugin in this way, or hey, maybe using your YAML config file. Now, I have loaded an input plugin that is called random, and that is called stdout. Let's dig into where random is. First of all, I started random with -i. -i means it's an input. And guess where the plugins are? In the plugins directory. And every plugin, depending on its types, we have what is called custom plugins, which we have just one. We have input, filters, outputs, and processors. So let's look for in random. So if random was an input plugin, the prefix in the file system will be in_random. Here we go. A plugin basically has a CMake file, which says, hey, this is the source code, and use some special macro to register the plugin and says what are the files that need to be compiled. And this plugin is pretty simple, I would say. Well, it's 200 lines. Maybe it's not that simple. What is this? It should not be here. Okay, somebody did it. Okay. A plugin pretty much has a structure that says, hey, this is my internal name. This is my description. As you can say, it says random. Now, look at this. If I say -h, you will see that the random plug is here. and it says random, right? This description comes from the source code. But let's modify it. Let's save this. I just modified this file in this plugin, and I'm going to run make. As you can see, the only file that was regenerated with this one, the others which we just checked. And the new change was compiled in maybe a few seconds. Yeah, in 13 seconds. If I do Fluent Bit -h again, you will see that the random has now all the description. Just in case you want to modify something or you found, you know what, hey, it says UDP, it means nothing. Maybe you want to add a longer description. Yes, don't add markdown and stuff like that. This is just a console. Now, this information is really important. This is like the internal name, the type of plugin, internal name, description. And the other are just callbacks that says, when this plugin is initialized, what we're calling before run it, the engine, what we do, this is null, do nothing. Collect, we have a collector because some plugin says I want to run every certain time, and that's a collector. The flash buffer, which is not used. Callback to pause when Fluent Bit says to a plugin, hey, you need to pause. This is a callback. This is when you resume, and when it's time to exit. And why the exit is important, because you want to release all the resources, close any file that you have open, do all the cleanup, right? And then the config map. And config map are just a way to define which configuration options exist in Fluent Bit. So I define the type, the name, a default value, where this is written, and a description. Now, what this part in the plugins are really important, because this is what is exported as options, right? Oh, this is what the plugin supports. And for example, you can do something like this. Remember that we were taking a look at random. You can do -i, random, -h, and will give you all the options for Fluent Bit based on the input plugin that you just described. And well, these are the kind of the global option that the plugin inherits since running as an input plugin. And these are the specific plugin options. These options here, samples, interval seg, interval nseg, come from here, from the config map. And if you want to do something more fancy, you can add -j instead of -h. And that will give you a JSON with all the options for that specific plugin. Of course, we can format that with JQ. And you will see, you get something more beautiful that you can use for documentation or your own app that you're building on top of Fluent Bit. Look, here are the options. Okay, so same as we have this input plugin. Yeah, if you modify here something that we recompile, oh, I guess you wanted to see it, right? Let's add a new option. str, hello, office hours. We're going to set it as null as a default. And we're going to do nothing here. We're not going to write because, hey, this is an invalid option. This is a test option for office hours 81. We just save here. We switch, we recompile. And when we rerun this, you will see that the option will change. So for anybody looking to contribute to Fluent Bit and see, that I didn't like the help of this in the binary, this is how you can easily modify it. And you will see that, yeah, I did it with -j, same as I did it before. Oops. And here's the new option that we just set. This is how you can hack Fluent Bit very easily. And of course, I don't want to commit this, so let's leave it as is for now. Then we have the output plugins. For example, we did out std out. That is here somewhere. This is the std out plugin. And same as input plugins, output plugins define their own output structure. Same thing, name, a description, callbacks, and this structure is a bit different because now output plugin says, hey, I'm an output plugin, but I'm able to handle logs, metrics, traces, profiles, and blobs, all the signal that support. However, there are other plugins that only support logs. For example, if you go to out Slack, which allows you to send us message to Slack, it will say, oh, if you don't have an event type, it will be just logs. And I think we have an exception with Splunk. Maybe we can take a look at the Splunk connector plugin. So at the bottom. Yeah. Oh, actually, this is a bug. Just found it. This is Splunk connector. Oh, no, it's not a bug. Yeah, because in Fluent Bit, we are allowed to disable signals, but I think that doesn't make sense because we have things so much integrated right now. But it says, hey, if we support metrics, register that we support logs and metrics. If not, actually, if this didn't exist, it will just process the logs. But why this is important? Because input plugins can generate logs, metrics, traces, and profiles, which is new. And not all plugins support those data types, those type of signals, and just some specific signals. And this is a way to say, hey, I'm an output plugin, this is what I can handle. Otherwise, that specific signal data won't be routed to that output plugin. Okay, so this is our input outputs. For processors, is kind of the same thing that runs attached to the input plugins or the output plugins. And filters are pretty much similar. Now, we don't want to deep dive into the plugins structure. However, what is interesting as well is the config folder. Hey, this is cool. I didn't know that. Is my Visual Code or not? I don't remember if I added an icon for these configuration files, but nice to see them there. These are all configuration files that we ship by default in the project. I think we should start putting the YAML files right now. It will make more sense. CPAC, which is for packaging. If you like to build Fluent Bit in containers, we have the Docker files here. So you can easily build, you don't need to touch anything. Other examples, how to do stuff with Rust, with Wasm, in Fluent Bit. And external dependencies, lib. This directory is quite interesting. We support external dependencies, right? But we try to minimize them and have what we really need, and we bundle them. And why it's important to bundle? We have seen a lot of changes in dependencies that are really easy to break our builds. Or sometimes, hey, if another dependency got a security issue, we just don't pull by default. So we just allow maintainers of the project to update those specific libraries, right? And I have to be really cautious right now with that, but I think we don't change them too often. However, yeah, this is how it works. A few dependencies, Avero, how to convert to Avero, CRS, which is this is a asynchronous DNS library. CFL, this is a CFloppy project from Fluent Bit. It's called CFloppy, which provides certain data structures to format time, utilities, key value, pairs, blah, blah, blah. Chunk.io, this is another thing library that we created for our storage layer. This is the one that does chunks buffering in memory, in the file system, support Unix, Windows, and that's all low level stuff. So we never want that plugins, do their own writing or flash to this. We would try to abstract that as much as possible. Symmetrics, our own library as well to manage encoding, decoding for multiple formats, from message back to hotel, to Prometheus, to StatsD, CloudWatch, Influx, and so on. And what else is, C profiles, which is for profiles, C traces. C traces pretty much an implementation of the OpenTelemetry traces spec, the schema. So this is how we support all the encoding from a trace from a C perspective endpoint. So input, for example, in OpenTelemetry, which is a plugin, receives a payload in gRPC or JSON. We take that content and we use the ctrace API to compose a ctrace context. And from ctrace, then we can encode back to hotel hotel or text or message back. Okay, so I think that we have walked through a lot about the source code. I hope that this session has been useful. And I want to remind you that we're going to stop here right now. Let me close here. That you can come back to this recording of this session anytime in case you have some questions. And of course, if you want to suggest any topic for the next office hours, you are welcome to do it. So thank you so much for watching this video and hope to get connected soon.